Hey everybody, I'm going to show you how to find the inverse of a function, and here we have two examples. The steps I wanted to go through to find the inverse of a function is first set to linear equation. All this means is set f of x to y. Step 2, swap x and y in the equations. Step 3, solve for y in equation 2. And step 4, I'm just going to write interval notation. Basically put it in as interval notation in your solution. And that is just f to the negative 1x. Okay, so let's get started on the first example. Here we have f at x is equal to 18x squared plus 3. And I wanted to find the inverse. So to find the inverse, let's go ahead and follow our steps. So step 1 says set f at x equal to y. So y is equal to 18x squared plus 3. Now we're going to swap x and y. So x is equal to 18y squared plus 3. And now we're going to solve for y in this equation right here. So solve for y. And first thing we're going to do is x minus 3 is equal to 18y squared. We're going to divide both sides by 18. And we're going to get y squared is equal to x minus 3 over 18. And so y is equal to the square root of x minus 3 over 18. Now, last step is we're going to put it in interval notation. So the inverse of f at x is going to equal to square root x minus 3 over 18. And that's our solution. All right, so let's move on to the next example. This example is a polynomial. So as you can see, there's two x terms here. The inverse requires you to determine, to swap the x and y's. However, it has to be in vertex form. So if you have a quadratic formula like this, let's look in the middle right here. Let's say we have it in standard form, which is what we have in this example right here. I need to convert it into vertex form, because that is what is required to find the inverse. So to turn it into vertex form, we have to complete the square. And completing the square is a very important thing to do here. So I see this polynomial quadratic function. I know I have to complete the square. So let's complete the square. And completing the square requires me to separate. First, I'm going to write down y is equal to x squared plus 8x plus 3. And first, I'm going to separate these two and this term. So I'm going to look at the term with the x's in it. And I'm going to be required to create a perfect square out of this. And a perfect square would be x plus a squared, for example. To do that, I'm going to take this b value, and b is 8. As you can see here, this is bx, or 8x. And I'm going to divide it by 2 and then square it. And so that's going to give me 16. Now what I do with this 16 is I plug it back into this function like this. Y is equal to x squared plus 8x plus 16. Now we know that we can't just add a number to an equation. if we add it, we have to add it on the other side, or we have to subtract the same amount on this side. So I'm going to subtract 16 because I added it. So now it's like I added 0 basically. And now we know we still have the plus 3 here. So now I have here my perfect square, and here I have my constants. If I were to factor my perfect square, this one right here, I would get x plus 4 squared. So that is it factored. And now I'm left with my constants, negative 16 plus 3. And I can just add the two, and I'm left with negative 13. Now I have my equation in vertex form. And now that it's in vertex form, I can find the inverse. So let's go ahead and find the inverse. Step 1 is already done for us, so I'm going to swap the x and the y. And I'm going to solve for y. So x plus 13 is equal to y plus 4 squared. Now I'm going to square root both sides, and that cancels out the square. I'm left off with square root of x plus 13 is equal to y plus 4. And my inverse is going to be x plus 13 minus 4 is equal to y. And that's going to be my solution. I'm going to write it as the inverse notation, x plus 13 minus 4. And that's my solution. So that's how you find the inverse of a function. Hope you liked the video. Thanks.